Welcome to my YouTube channel. Today I am going to explain wavelength of laser light experiment. So my dear students, this is one of the important experiment in engineering applications. So why? Because we are determining the wavelength of the given laser source by using grating spectrum. So here the apparatus are, so this is wavelength of laser source experiment. So what are the apparatus? Here this is laser source. So this is laser source and this is off and on. So here laser source, diffraction, grating. So this is laser grating. So here grating spectrum consists of 2500 lines per inch. So my dear students, one line per inch is 1 by 2.54 centimeters. Then you can calculate number of lines per centimeter, 2500 divided by 2.54 centimeters. Then we are getting Kaplan value. And also coming to optical bench. So here we are arranging the spectrum by using optical bench. So here the laser source box and optical bench, so both are in same heights. So my dear students, you have to observe like this one, laser source and optical bench both are the same heights. So here the grating spectrum inserted in the optical bench. So here when laser source, so and also meter scale, one of the important equipment is meter scale. So why? Because we have to adjust the distance between laser source, grating spectrum and the screen. So here we are using the wall as a screen. So here keep the distance between grating spectrum and the screen. So here according to the phenomena of the diffraction. So according to the phenomena of the diffraction, so when laser source is passing through the grating spectrum, so here the central maxima, we are observing central maxima, first order, second order diffraction patterns. So central maxima, first order, second order. So here this is the right side and also left side, first order, second order, third order, etc. So here coming to the experiment, so when laser source is passing through the grating spectrum, so the different diffraction pattern can be observed on the screen. So this is the actual phenomena of the wavelength of laser source. So here what is capital D? So capital D means the distance between grating spectrum and the screen. So here keep the distance. So here keep the distance 50 centimeters. So initially, so we are taking 50 centimeters and focusing the screen. Then coming to the diffraction pattern, central maxima, first order, second order. So here, my dear students, the distance between grating and the screen. So here we are taking 50 centimeters between grating and the screen. Then we are observing first order and second order. Then we are observing first order and second order. So here this is central maxima and this is first order and this is second order. So similarly first order, second order, left side. So here like this you have to bubble here on the rough paper and take down to calculate the distance. To calculate the distance by using small scales. To calculate the distance by using small scales. So capital D means distance between grating spectrum and the screen. And small d means the distance between central maxima. So this is central maxima. So this is central maxima and this is first order. So the distance between central maxima to first order, that is D1. This is D1. And the distance between central maxima to first point, that is first order in the left side. So D equals to D1 plus D2 by 2. So left side, note down the distance. For example, 2 centimeters left side and right side 2 centimeters. So the average D equals to D1 plus D2 by 2. So for example, D1 2 centimeters and D2 2 centimeters. So 2 plus 2 4. 4 by 2 equals to 2 centimeters. Then coming to theta. Theta equals to tan inverse of small d by capital D. So small d means average, already we have calculated. Capital D means distance between grating and the screen, that is 50 centimeters. Then you can calculate theta value. So theta equals to tan inverse of small d by capital D. So the value of small d and the value of capital D. So by using the calculators you can take the theta value, then you can write in the tabular column. Then you can write in the tabular column. Then coming to lambda value. So what is our aim? To calculate wavelength of the source. Lambda equals to sin theta by small n into capital N. So here we are taking theta value. Then substitute in the formula. Lambda equals to sin theta by small n into capital N. So sin of, so coming to calculation, lambda equals to sin of theta value. Sin of theta value divided by small n. So here first order means n equals to 1. Second order means n equals to 2. So second order means n equals to 2. First order means n equals to 1. And capital N value. So already I have told in the number of lines calculating. Number of lines per centimeter on the grating. So n equals to 2500 lines per inch. So 2500 divided by 2.54 centimeters. So that capital N value 984.25 lines per centimeter. So that you can substitute in the formula sin theta by small n into capital N. So if it was first order, then you can take n equals to 1 and you can put n equals to 1. Capital N value is 984.25. So this is the first calculation. Similarly, for second order, n equal to 2. So coming to, already note down the in the previous session. So we have noted central maxima, first order, second order. So first order, second order. So from the pattern, so from the diffraction pattern. So that again you can note down central maxima to second point. Central maxima to second point. Take down the distance. Similarly, central maxima to second point. Note down the distance. Then you can note down the values left side and right side. Left side and right side. So mean value D equals to D1 plus D2 by 2. Theta equals to tan inverse of small d by capital D. Lambda equals to sin theta by small n into capital M. So like this you can calculate from the first distance D equals to 50 centimeters. Similarly, you can note down, you can vary the distance 60 centimeters. You can vary the distance 60 centimeters. So here like this you can vary the distance 60 means, so here this is 50 centimeters, okay, so 60. So here this is 60 centimeters. Then you can focus on the laser light passing towards through the diffraction grating, and you can observe the diffraction pattern on the screen, that is central maxima, first order, second order. So first order and second order. So like this again note down the values of theta 1, theta 2, then theta equals to D equals to D1 plus D2 by 2, theta equals to tan inverse of small d by capital D, lambda equals to sin theta by small n into capital M. So my dear students, you can vary the different distances by using either 50 centimeters, 60 centimeters, 70. Then you can note down the values in terms of central maxima, first order, second order. So similarly left side first order and second order diffraction apparatus, and you can note down the D1 value and D2 value from the left side and right side and take the average, and also you can substitute in the theta value. Theta equals to d small d by capital D, and also tan inverse of small d by capital D. So finally lambda equals to sin theta by small n into capital N. So capital N equals to 984.27 lines per centimeters. So by using, here we are using red laser source. So you are observing red laser source, so that as per theoretical value red laser source wavelength is in terms of 6000 to 7000 angstroms. So similarly here in the experimental value also you will get in terms of 6000 to 7000 angstroms. Then the final experiment is correct. So if you like this video, please like, share and subscribe my YouTube channel. Thank you.